Today we see first unit, sets and function. In that, first we see sets. Definition of set is well-defined collection of objects, where well-defined collection means collection shouldn't change from person to person. Change from person to person. For example, we say, first example, top 4 cricketers. Top 4 cricketers In that, someone say Amit gives answer. He say that top 4 cricketers are Sachin Tendulkar, Kapil Dev, Ricky Ponting, and Virat Kohli. Okay, and next Anil says the top 4 cricketers are Clark, Yuvraj Singh, next Bumrah, and Dhoni. Okay, if we see both persons, Amit and Anil, Amit gives answers. Amit says that 4 top cricketers are Sachin, Kapil, Ricky Ponting and Virat Kohli, and Anil says Clark, Yuvraj, Bumrah and Dhoni are top 4 cricketers. Both of the persons give different cricketers. So here person vary. Therefore it is not well defined. Therefore it is not set. Okay, that is, if we change the person, they will give different names of 4 cricketers. Okay, so the set of top 4 cricketers will not be formed. Therefore it is not well defined. Therefore it will not be a set. Next example we consider natural numbers less than 10. So again Amit will give answer 1, 2, 3, 4, 5, 6, 7, 8, 9, and Anil will also give answer 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, both person, if we ask anybody else, he will also give the same answer, because natural number less than 10 are 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here the set remains same. Therefore here the set of natural number less than 1 is 1, 2, 3, 4, 5, 6, 7, 8 and 9. Therefore here set is defined. Okay, next, now how to represent a set. Now set is represented in curly bracket, okay, and the elements in curly brackets are separated by commas, and the notation of a set is always a capital letter, okay. For example, set of vowels, in that if we consider a set A is equal to, we know that vowels are, which are vowels? A, E, I, O and U. These are vowels. Therefore, set A is equal to, now we have to represent the set, therefore set of vowels where A is equal to curly bracket, this is curly bracket, A, comma, E, comma, I, comma, O, comma, U. So we represent this in the form A is equal to and curly bracket close. Okay. Okay, next point. This is definition. We have studied definition. What is definition? Set is well-defined collection of objects. Here, example which is not a set, and there are two examples, set of natural number less than 10 and set of vowels which are a set. Now next point is representation of a set. Representation of a set. Okay. Set is represented in two types, which is roster form. Roster form, or it is also known as tabular form. Tabular form and set builder form. Set builder form. Okay. In that, we first check the example of set builder form. If we consider a set A is equal to X such that X is odd number, X is odd natural number, odd natural number less than 10. Okay, that is, in a set X is such that value of X is such that condition is X is odd natural number less than 10. This is a set builder form. Now we have to write it in roster form. We write this in roster form as A is equal to, that is, we have to write the values of X which are less than 10 and it is odd natural number. What is which are the odd natural number less than 10? First, we have to know the natural numbers less than 10. We have given examples above only. The natural numbers less than 10 are 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we have to find odd natural number. Okay. Now, from this, the odd natural numbers are, which are odd natural numbers? What do you know about odd numbers? Odd numbers are which are not divisible by 2. Now in this 1, 3, 5, 7, 9 are odd numbers. Therefore, a roster form of this set will be A is equal to 1, 3, 5, 7, 9. Okay. Again we say second example. In second example, if we consider set B is equal to X such that X square minus 3X plus 10 is equal to 0. Now this is a set builder form of a set B is equal to x such that x square minus 3x plus 10 equal to 0. Now this is a quadratic equation, so we can solve it as x square minus 3x plus 10 equal to 0. We have to see the factor of 10 such that its value will be minus 3. Okay. Now factors of 10 are 5 and 2. Now minus 5 and plus 2 will be the factors of 10 such that we get minus 3. Minus 5 plus 2 is minus 3. So we write it as x plus 2 into x minus 5 equal to 0. Therefore we have two values, x is equal to minus 2 and x is equal to 5. Therefore in roster form or in tabular form, set B is written as B is equal to minus 2 comma 5. See next example of set builder form. We choose a set A is equal to x such that x is an divisor of 21. We say that positive divisor. Here we add positive divisors of 21. As positive divisors of 21, we have in raster form we can write which integers are divisors of 21. Only positive integers we take here. 1 is divisor of 21. Is 21 is divisible by 2? It is not. We get in point value. Next 3. Next 4 is not possible. 5 is not possible. 6 is not possible. Next it will be 7, and I think lastly it will be 21. So all divisors of 21 are 1, 3, 7 and 21, where 21 itself is divisor of itself. Next example again, we see that if we see B is equal to set x such that x is an integer less than 10. Now in this example we have x is defined such that x is an integer less than 10. Now less than 10 there will be a negative values also. So we start from now neutral value is 0. Okay. We have to find integers less than 10. Therefore 0, minus 1, minus 2 and so on are all negative integers, which negative integers will come in this set, and after that 0 it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this will be roster form of the set x is an integer less than 10. Okay, now we go to next point, equal sets. Two sets say A and B are said to be equal if they consist of the same elements. Okay, for example, let A is equal to set 2, 3, B B is equal to set x such that x square minus 5x plus 6 is equal to 0, and C is equal to set 2 comma 2 cube upon 4 comma 6 upon 2. Okay, here we see that A is equal to 2 comma 3, B is equal to x such that x square minus 5x plus 6 is equal to 0, and C is equal to 2 comma 2 raised to cube upon 4 comma 6 upon 2. Now here the elements in a set B are the values of x such that x square minus 5x plus 6 is equal to 0. First we have to find the values of x. Now here x square minus 5x plus 6 is equal to 0. That means we have to find the factor of 6 such that it should be minus 5. Okay, we have to find the factor of 6 such that its calculation will be minus 5. Now factors are 2 and 3. 2 3s are 6. We have to find the values should be minus 5. So here we take minus 2 and minus 3. If we add these both, minus 2 minus 3, we get minus 5, and product of this minus 2 into minus 3 is 6. So we can write x minus 2 into x minus 3 equal to 0. That is, we get two values, x minus 2 equal to 0, which is 2, and x minus 3 equal to 0 gives value 3. Therefore set B contains again values 2 comma 3. Now if we see the set C, in set C 2 cube upon 4 means 8 upon 4 is equal to 2, and 6 upon 2 which gives again 3. Therefore elements of a set C is 2 comma 2 comma 3. That is, we can write C is equal to 2 comma 2 comma 3. But same elements 2 and 2 are same, so we can write it as a single element 2 comma 3. In set, please remember it that in set no element is repeated twice. If it is twice, we write it as a single element. So C can be written as 2 comma 3. If we say we see three sets A, B and C, we can say that A is equal to B is equal to C. That is, three of these sets are same but written in a different form. Okay, so this is all about equal sets. If we recall again definition of equal set, it is two sets, say A and B, are said to be equal if they consist of the same elements. That is, the set A and set B consist same elements, so we can say that it is equal sets. Now if they are not equal, we say that it is not equal set. That is, if A and B are not equal sets, we write as A not equal to B. For example, if we take example, A is equal to 2 comma 3 comma 4 and B is equal to 2 comma 3 comma 5. We see that number of elements in both sets are same, but in set A there are elements 2, 3 and 4, and in set B there are elements 2, 3 and 5. The element 4 is not present in set B, and element 5 is not present in set A. So we can say that set A is not equal to set B. Now we see finite set and infinite set. Infinite set. Finite set and infinite set. Now, in finite set, we say that a set is a finite if the elements of a set are countable, or which is finite is known as finite set, and if the elements of a set are infinite, then it is infinite set. If a set contains a finite number of elements, it is finite set, otherwise it is an infinite set. For example, A is equal to set of days in a week. Set of days in a week. Set of days, which is example of a finite set. Okay. Now, here second example is B is equal to x such that x is an integer. Now integers are positive numbers, positive integers and negative integers. So we write from neutral 0, 1, 2, 3, 4 and so on. Okay. We does not know the last integer which, okay, so we write it as ... and we check the left side is of 0 is 0, minus 1, minus 2 and so on, minus 2, minus 3, minus 4 and so on. So this is an set of integer. So here also left side is not, we does not know any smallest negative number integer, so we write it as ... Therefore, a set B is infinite set. Okay. Thank you. Now we stop here.